Python and the level of the language that you learn from 131 for Python, that is, if we scale from 0 to 100, I think that is bottom 10, which means there are a lot more that you have to gain, okay? Particularly, for example, you need to gain the skills that you handle something that you enjoyed with Wireshark. Can you make it in Python? I'm not talking about visualization. I'm not talking about graphics, user interface. That's a fancy, right? But internal, the engine, real core engines, can make it in Python. Yes, you can, right? If you do a little more, just simple more, okay? Can you play your music in your Python? You can do that, right? Have you heard of some of the music play from your Python codings?
I think so. I mean, I have like a vague memory from my class with Professor Bonavar.
Right, yeah. Yeah, we can do code. Piano code is much simpler that we can code in Python. Why? Piano, there's a keyboard, there's a fixed frequency of sound, right? Fixed. What about violins? That is state of the art. Any string like violins, then frequency is really wide. But piano is standardized. There's one of the easiest thing that you can play in the language, like a harmonica. Harmonica is also simple ones, right? Nothing more than harmonica that you can do in piano. Okay, so all the electronic device can be handled by Python. If you can handle a Raspberry Pi, then you can handle Raspberry Pi that you have handles only digital signals. Okay, your Raspberry Pi that can carry only the digital signals. What if we have analog signals? Then there's another microcontroller called Arduino Uno. Arduino Uno has the digital pins and analog pins. So we can plug analog pins on Arduino Uno and then get the signal from that Arduino Uno here and Raspberry Pi. They can communicate together. Once you set up analog signals, you also handle the analog signals, then you can do unlimitedly many devices, from medical devices to any physical plants. Okay, so there's unlimitedly many cyber physical infrastructures available. That is, and security management there is your job. Okay, so that is very one of the secure the platform that managing those cyber cyber or cyber physical infrastructure is Linux. Okay, that's what we are looking at. Okay, topic for today is the securities. Start with some of the concept. Linux security. Linux has evolved into one of the most popular and versatile operating systems. So a lot more than Unix. Okay. If some systems should be running highly secured and top and platform, then it is called the Solaris. Okay. But Linux is good for us. Once you know the Linux, you can handle others. Many features mean broad attack surface, So we will learn the features, can create highly secure Linux systems. We'll review discretionary access control. There are two types of access control: mandatory access control and discretionary access controls. If it is a mandatory, so basically we start with the mandatories. So what it does is, what is access controls? So we need to control what subject can do on what object. So there are two players, subject and object. When you see mandatory access control, then subject and object both has some level of securities. You can think of that access control in our real world, okay, not the cyber world, our real world. I don't think anyone here got military experience. Anybody has military experience here? Veterans? No? Okay. So you can imagine, okay. In military, lots of documents, right? Some documents can be classified. Some classified documents. Then start from top secret, secret, confidential, and then many of the documents called unclassified. If it is unclassified, then anyone can see, anyone can read, right? That is object side. So we can think similar things, similar level of securities on subject side. Okay, so for example, I'm thinking of these three guys here, Frederico, Evans, and Obaid. Okay, three of these guys. So Obaid, he has top secret clearance, and Evans, he has the secret clearance for secret levels, and Frederico, sorry, he doesn't have any secret clearance. I have here documents, okay? So this document is top secret clearance required. This document is confidential. So guess, if this is confidential, who can read this? Evans can read because he has secret level clearance. And Obaid, of course he can because he has top secret clearance. Frederico, sorry, he cannot, right? He cannot access this. That type of things can be coded in Linux, for example. Okay, Linux has lots of files. So we can say, hey, these files, by the way, access, the way of access, also maybe not only simple access, but different types of access possible. Can we allow him to read, or to write, or to execute? We're talking about this Linux platform, right? In real world documents, then we can say, can somebody read this? Can somebody copy this if that is hard copy materials? Or we can say, can somebody modify this, rewrite this, right? That type of things. Those types of access. Then we have subject, object, and types of access. So lots of the connections between subject and object through different types of access. Okay, so I want to think that is basically that we are going to handle for mandatory access. On the other hand, so mandatory access, then subject object fixed already, right? Hey, this can be read by top secret clearance employees only. So everything is fixed. Discretionary, on the other hand, that is a more advanced way of controlling access. Therefore, there's some policies, rules, so we can apply that rule. We don't really assign secret clearance, top secret clearance to each individual subject, each individual objects, rather than mandatorily assigning secret levels explicitly, but we set up the rule and to see if this guy can read or write on some of the objects. That kind of some of the process, some enforcement mechanisms needs to be involved. Okay, that is discretionary access control. If we are thinking of discretionary access control, then not only by name. If we're thinking of a subject, then as far as, for example, my email is Jae-yoon. As far as Jae-yoon login, Jae-yoon can do everything, all the privileges assigned to Jae-yoon, right? But in discretionary, me, Jae-yoon, I can access my platform as a regular user, or I can access to, for example, as a professor, or sometimes as an instructor, or sometimes as a department chair, or the school dean, or provost, or whatever the job title that I might have, right? So I can access the same platform, me as Jae-yoon, but with a different role. So depending upon the role that I am currently logged in, I might have different privileges. So a lot more fine granular level of controls that's possible in discretionary access control. Okay, so in order to that discretionary access control, it's not simple Linux. It's not simple mechanism that's provided from Linux operating systems itself. It requires some of the state-of-the-art work. By that I mean you need to do some of the codings. Okay, coding is needed. Okay, and Linux security also review typical vulnerabilities and exploit in Linux and best practice for mitigating for any threats and new improvement to security, Linux security models. Linux security models, the traditionally, root has everything. Root has all the privileges, almighty privileges, okay? Other accounts can do much less. Hackers wants to get, therefore, root privileges. How come any unknown hackers can get in root privileges? If you see the programs, operating system is nothing but a collection of programs, right? That's what we also practiced, and I expressed that earlier. There's a collection of programs. Some programs cannot be executed locally. Some programs needs to do some level that requires root privileges. You are not root, but your program needs to be handled by root privileges. One of the examples of activity is in your program, if you say, I want to access some of the data through the internet, because there is the cloud server where there is some of the data, so my program needs to access that data. Think about the privileges. Your privileges is yours, right? Do you think only with the privileges owned by you are enough to get on the internet and access to the remote server and get the data from there and all the way back to my program that I am currently running? Do you think it is? No, it is not, right? You do not have any privileges to get on the internet by yourself. You don't have privileges, something that you can handle the printer, right? For example. Do you have any access, the privileges to access that printer? No. But when you run your program may be able to access the printer, right? You see some discrepancies? Some of those that you do not have privileges, but if you write some code and when you execute that code can access that, right? How come it is possible? That is what operating systems can do for you. So there is some levels of, we call that kernel levels. So in the kernel levels, most of that system, the routines is nothing but that is also programs, requires root privileges. When you print your code, it should request to execute system level program. So system level program knows how to handle that printer, not your coding list itself. Your coding list is very high level, so you can simply say print that language or click some button. Then it goes to that highly sophisticated top level securely sensitive programs to be executed. That is executed only by root privileges. So somehow when your program goes through that channels, along that channel, root privileges involved. So what hackers can do is to tap into that root privileges at that point. Then you will have the root privileges. It's a very high-tech attack, right? That type of things. Linux security model run robust and secure Linux systems, and also discretionary access controls. So this is a model. We have subject and objects, right? So subject wants to take some action. Subject is nothing but the user itself, but subject can be a process. What is a process? Process is nothing but the program, your program. When your program runs on the operating systems, we call that a process. When we code on Python, then we call that a Python program, right? So subject could be you yourself as your login ID, or the program that you want to execute. Then somewhere in your program, or manually by you, some actions needs to be taken. So actions, it could be read, write, or execute. So we have objects. Usually we call that file. In Linux, file directory is also type of a file. A little different. It's not like Windows. Very, very homogeneous here in Linux. There are some special files. Files that can very, very like frozen files with the sticky bit. We call that sticky. So sticky bits assigned to that file, then it cannot be modified. There is a kernel levels, so object permission may be derived from there. That type of things is Linux security. Permission command that we are going to look at. ID, if you type ID, then it displays user identity, but usually not all of these commands are available on Linux. I mean, the Raspberry Pi OS. Raspberry Pi OS It's kind of deviance, but not exactly. So if you do ID, if it's not working, it's not working. But if you see here, so lots of information about you. User ID is 1,000. Group ID 1,000. And it has a little bit of admin things. And also it has sudo. Some games, some video, audio can be done. Okay, some of the GPIO. What is GPIO? In Raspberry Pi, you have GPIO pins. There are 40 pins. All of them are digital. There's a ground pin and some power supply pins. If we say that is not digital itself, then it may be analog. But in general, data, if we are handle data, then all digital data, not the analog data. So those are the something that you can see yourself, right? And then there is a change file mode. So what do you mean by that? Here, if we say ls minus l, then we see some of the temp files. Temp file is not executable. If we say all other files, it has X. X is added in addition to some of the code assigned to temp itself. Temp has RW, R for read, so readable. X for executable. So temp itself is not readable, but all others are executable. What do you mean by executable? It could be, if it is an executable file, then it is an executable, that's a command that you use, or that's a program that you want to run. But if you see here D in this code, anything that starts with the D, then that's the dictionary. I'm sorry, directory. There's a directory. There's a called, in other words, folder. Folder has, is a folder executable? What does that mean? It means we can open that folder. It's not really execute, right? Open the folder. So how can you do that? We can do cd and then John Yoon, then we can open that folder. We can get in that folder. Not only open it, we can get in, right? Can we change this kind of code from XR? Here, for example, John Yoon. John Yoon, WXR, dash XR, dash X. So what? Actually, it is RWX, all dash X, and all dash X. Okay, that's what John Yoon has right now. Some of the access mode coded in that way. Can you change it? Yes, we can change it using this command. We can change the mode, so it is called CH mode. So we'll do that. UMask, set the default file permission. So UMask is set. So command that you mask, then you can see 0022, 0022. So you will see that what 0022 means. There's a number. If there is a UMask, it can be, so real privileges that you have is something that you can, some number subtracted from that UMask, 0077. Okay, so you can subtract 0022 from full mask is 7777. So if you subtract 0022 from 7777, then it'll be 7755. 7755. Let me quick guide you to that documents here. I think that's toward the end. Here, not this. Okay, here. If you add all of this, it is 7, right? I said 7755. If you have 7 privileges, then you have all the privileges. Read, write, execute. Okay? You add them all. If you have a write and execute privileges, then what would be the number? You add them, 2 and 1. So number 3. If you have the privileges of read and write, then number 6. If you have privileges of read and execute, read and execute, then there's number 5. Okay, back here. UMask, if you get the number coded privileges for a file, I would say John Yoon here. John Yoon, on his own, he can do read and write and execute. The group where he is, read and execute, and all others can read and execute John Yoon's files. I said this UMask is used to get by default. This is all default, by the way. We didn't change it, the mode yet. By default, these guys get this UMask. So how can you get the privileges for default the files? Then you need to get the number from the subtraction. This number from 7777. So what is the number that you gain from there? 7755. What do you mean by 7? We're talking about this 7. 7 means we can do everything. Myself, I can read, write, and execute. That means 7 from this. So if we subtract 2 from 7, then we will get 5. 5 means 4 plus 1, then that is 5, which means I can read and execute. So by default, all the files read and execute. Read and execute. See all the files here, apparently they are all the directories. They have read and execute. Read and execute. This level read and execute coming from the subtraction 2 from 7, so this number. And the last one here, all-x coming from the last number here, number 2. Subtraction number 2 from 7. Therefore, that is 5. If it is 5, back here, there's nothing but read and execute. Therefore, that is a code, read and execute. Okay, write, there's no write. Therefore, we say dash. A little bit confused, right? A little bit systematics. That's what Linux is. Very, 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 very systematic, well-structured privilege management. Do you understand a little bit? Ariana, you understand? Yes? No? Yes? Can you explain? Can you explain why this temp file has this? Okay. To get, if we want to change anything that's given by default from UMask, then we need to use that command, chmod. Then we will look at that. See here, chmod. Change the file mode. UMask, that's the default settings. SU, what is SU? Huh? Super user. That is a command, super user. Right now you are here, right? So you are pi. And right. Do you have some type of super user privileges? Yes, you have, because you have sudo. Okay. Are you a superpower user? Are you a super user? You are not, right? There's some limited ones. But if you do su, then you are the root. it requires the password. Let's see. Failure, right? I do not have super user password, but can I I get that point, right? Yeah, a little later. I think later we have something, right? This is you log in as a root, okay? You log in as a root. Sudo is you execute some sensitive commands like the root. So you are almost all the privileges that the root privileges had, right? Root has. To do that, you can do sudo. We've done that so far a lot, right? When you install something, then you do sudo apt and then install and something, right? Python 3, whatever that you want to do, install, right? That is just what sudo can do. Chown. Some of the files here, who owns these files? Music, for example. It's owned by Pi, right? This is not really, this is a Pi, but it's not really the root itself. But if you do ls-l and usr, then it's called the root here, right? Here is called the Pi. This is a root. And then group is a root group. That is a sudo. Even if you are in Pi, if you are in the sudo's list, you can do this. What I mean by that here is you can do, like an owner of this, read, write, and execute. Okay. Change the group. We can also change the group. This group is currently root, but you can change that. Others. Password. You can change the password. So remember that we said su then equals to root, but I do not have the password, right? In order to change the password for the root, then you need to do sudo password wd and root. There's a new password we can set up. I put mercy. Okay. Now if I do su, now I'm root, right? So one of the homework assignments is I want you to change it. I want you to change your root password and show this. You need to change your root password, update it successfully. Next, you can get in the root to direct root. Now you are root. The warning: don't stay as a root longer. You may mess up as a root if you don't do anything properly. So you better exit. Just make sure that, oh, I am the root. That's it. And then bye-bye. If you stay there longer, you forgot you're the root, you do something, so that may mess up your operating systems. Your full operating systems may not be working next time. The work as you, Pi, or your name as the one that you originally set up when your Raspberry Pi was first installed, right? Okay. File system security. In Linux, everything as a file, as I said, right? IO2 device is a special file. There is a special file. For example, USB. Your Raspberry Pi, it has a USBs, right? If you want to access this one of the USBs, then that is available in that DEV. So CD/DEV, so device, and ls. Then we can see what we have. These are the device. So that is a GPIO pin number 0, 10, 11, 12, 13, GPIO, MEM, some of the RAMs, TTY 33, something that is terminals that we are working on. Some of the network, that is also device. Support, that is the device. Disk. Currently, my Raspberry Pi does not have settings for USB port. It could be literally called the USB, or if it's not, then so another name is ACM, but ACM is not shown here. Okay, so that is for this. And about the special files like named pipe, connected between the process and programs, and file permission that we looked at already, right? So we know if it is a RW, then owner, this first, the very first number that tells me whether it is a directory or a file. If it starts with a dash, it means simple files. And the next three characters, something about owner. So it tells me what owner can do. Owner can read, owner is authorized to write, but owner is not authorized to execute, RW dash. So owner can read and write. And next three characters tells me the group. This is for the group. So group, if you are in that group, although the file is not created, owned by you, but because you are in the group where the owner of that file is belonging, therefore you can also read it. So this is group. If you are in that group, then you are authorized to read it. The next three, this is anyone. It's called others. Anyone can do. So for example, any one of this, you are not the owner, you are not in the group, therefore you are not root, you are not in the group of a video, you are other, then you need to see whether I can do. Can I read? Can I write? Can I execute? No. If you see this, right? Is there anything that I can do? If you scroll that up, then there is something here. There's a floppy drive, some other drives, right? You can do standard error, standard in, standard out. What that means is that you can, standard in means this is a keyboard. So you are not root. You are not in root group, but you are other. Still, you can do read, write, and execute. Therefore, you can do that. You can handle your keyboard, right? Similarly, standard output, that is a monitor. So you can display your work on your monitor. You are not root, you are not in the root group, but you are other, but you could do according to this, okay? Serial port, like HDMI, that is kind of a serial port, so you can handle that. Yeah. Okay. So I think this is. Any questions so far? So access control is very, 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 very systematically controlled, right? In Linux. So once you know, then you can clearly see what it is, how you can handle systematically. Change file permission. Okay, now we have a change file permission. CH mode. And then remember we use a number 755. So what is 755? The last single digit number is for others. Second number is for my group. The first number here, that is for me, myself, owner. So what is the 7? 7 means I can do anything, read, write, and execute, right? Number 5, how can you get number 5? Number 5 can be by adding 1 and 4, right? 1 and 4. Each action is coded 1, 2, and 4. Using that 1, 2, and 4, if we add them, 2 numbers added or 3 all added, end up we having all distinct numbers. If we have 1, 2, 4, 3 numbers, adding 1 to 1 or adding all of those, we have all different numbers. 1, 2, 3, 4, 5, 7. Okay? 1, 2, 4. There's no number 3. Number 3 can be obtained from 1 plus 2. So no, not number 3, right? Number 4 is read. Number 1 is, I think, execute. Right? And number 2 is write. Something like that. I don't remember that. Okay, so what do you mean by 7? I explained that. Owner has a full permission. Number 5, group has read and execute. And others can read and execute. So we can make like this, or we can use some of the symbols, okay? So U plus X, then I want to grant execution privilege to user. I want to grant, minus means I want to revoke the write privileges from group. I want to grant, because plus is a grant, minus is a revoke. I want to grant read privileges to others. So we can practice that here. Okay, come back by CD so that I have this. Temp. Temp is read, write, read, dash, dash, read, dash, dash. So can I give, for example, CH mode to other to grant what is missing now? Read, so execute and write. So I can say execute to temp. And then if I see this, then I can see temp has this RW dash R dash dash R dash X, which is not the same as the privileges, right? It has been improved. I'm not sure it is improved, but changed. We can make this by number. So let's change it to John's directory. There are many, so I can ls minus l. Okay, there are many. So I can do, for example, chmod 755 sample.txt, the last file. I changed it to 755. Can anyone expect what this code would be? Ashley? Try. If I change the mode to 755, 7 means I can do everything. So first 4 characters will be dash RWX, right? Number 5 comes from what? 4 plus 1, which means read and execute, right? So it'll be R-X to the group and another R-X to others. Okay, when I change the mode, and then when I get that, as I said, the last ones, RWX, R-X, R-X, because I have this 755. Then you may say, oh, if I am, let's see. We looked at this, but let's take a look at this. I want to create users. So add a new user. For that, we need to use sudo add user and username. Then that new username, name itself is new user because I said new user here. And that is created, the home directory is created under /home/that name. Okay, so that much. This is another homework assignment. So what I want you to do, sudo add user, and I want you to put your first initial and last name, like your email address. Okay? So sudo as user, your first initial followed by your last name, hit enter. And then it asks you to enter the password for that JUN. So I would say Mercy and retype Mercy. Enter the new value, press enter the default full name. So here you can say, oh, that is my full name, John Yun. And then room number, MT 425. Work phone, 914. 674-7461. That's my Dobbs Ferry office number. Home number, you don't need to say. But you know my cell number. I do not have my home number, by the way. Other Joy. Is this information correct? Yes. Adding new one. So where I am right now, I am pi. So when I go back up at the parent level, cd ... and ls, oh, I have another JUN. right? Jaeyoon, me, myself only group created right now. So ID, who am I? Now pi, right? So I forgot. Sudo login for secure shell JYON. No. Sudo no su no not su. I forgot that command. This is sudo is su is a superuser. How can I log in? Let's see. Let's find out. Okay. Is it called a login? Oh, it's called the su dash. Okay. Thank you. Okay. So if I want to, right now, me, pi, right? Of course I have here. If you want to log in another name, Jaeyoon, then su space dash Jaeyoon. It asks me to enter Jaeyoon's password. Where am I right now? Jeonyoon. Okay. So can I see pi? No. Oh, not in here. So go back up. Then I see pi. So can I go pi? Permission denied. Okay. So we can make another. Okay. So this is pi. This is a Jaeyoon. This is a pi. Back up. ls minus l. So no one's can. Here, right now, ls minus l. Then no one's. As a pi, I want to allow Jaeyoon to come in my directory. What should I do? Can anyone? Juliana? Juliana is working so hard. If I see her fingers.
I guess
Okay, Dimitri.
like permissions to the Jaeyoon user.
So what is the command to do that?
Command.
chmod. Are you going to do with the number or symbol? You can do two ways, either using symbol or the number. What I want to make here, I want Jaeyoon is other, right? Jaeyoon is not my group. So I need to handle this, the last three characters. So in that last three characters, I will allow Jaeyoon to come in my directory, which means read, write, or execute. Which actions? It should be the execute action. Change directory is execute. It's not read, it's not write, right? So we need to give execute to others. So for example, then others, we want to plus x to y. To which file? Pi file, because pi is me. I can handle it, right? Pi. So I want to change that. And ls minus l, then I have here x. So anyone can come in me. So here, Jaeyoon. As a Jaeyoon, Can I now CD pi? Yeah, I got it. See here? Pi. ls minus L. I am getting, but I cannot do anything. Because when I see here ls minus L, then, oh, this is me, right? Oh, all others can do read and execute for this. Oh, ls minus L, this is a special command. This is not allowed. But here, I can get in because this guy, anyone can get in, for example, John Yoon. So can I get in John Yoon? Although I do not execute this command, but can I get in John Yoon? Yes, you can. If you, so this is very secure. I let you in my directory, but you cannot see what I have. If you can see what I have, then that is big release. That is another vulnerabilities, right? But because you are a friend of mine, because you know I have a John Yoon directory, hopefully you can get in. So I can get here, CD, because you know my name, John Yoon. I can get in John Yoon, right? So I can get, but I cannot do ls minus L. Oh, there I can do ls minus L. Oh, that's good. Because I let you in my directory. So can I now read anything? For example, command.txt. I'm now Yoon, right? I'm in Pi's directory where there is a John Yoon. So can I read command.txt? So cat commands.txt. So I can read it. So what is PWD? PWD is this. What is my ID? My ID is John Yoon. I am now in PI's home directory. Okay, that is another homework, right? Question? So now how to manage it, right? You can create your friends login, and you can control their access. If you do not want them to make a home directory, then you can say sudo add user, here username, but there is an option. -- no create home. Although I give you an access to my platform, you do not have your home. But you can come in, but you cannot save your stuff on my system. You may read, you may download, but you cannot upload. Well, sometimes you can make it upload, but not into your home directory. That's quite possible, right? So this is quite common in most cases. Let's say you are working for a newspaper, New York Times. You are a reporter at New York Times. Now you are dispatched to where? Ukraine, okay? Good example. You are in Ukraine. Which one is the most dangerous spot right now? South Korea? Ukraine? Maybe Ukraine, right? Gaza? But anyway, you are the reporter there. So you collected the photos. So you want to send it to your home server here in New York City. You are as a New York Times reporter. Then you have an access to load, right? Upload. You do not need to save any photos on your own directory. If you save your photos on your own directories, then while you are there, here in New York, it cannot be printed because that is yours, right? So I allow you to, you have a login ID, but once you log in, then you can change some directory to somewhere, not on your own directory, but someone else's directory, like desk. Okay, it goes to desk so that it'll be printed tomorrow morning. So you can get in, right? In order to make that, then you need to do, again here, can you make, as Jae-yoon, can you make a new user ID? Sudo add user reporter. Can you make it? Oh, is it possible? MA sudoers. Password for John-yoon. Okay, mercy. John-yoon is not in the sudoers file, right? I cannot read. I cannot create new user, but Pi has that privileges. So sudo add user reporter, but I will give him that option. So dash no dash create dash home, no create home. Okay, so we can make here dash no create home reporter. Adding reporter, adding new group reporter, adding new user reporter with group. Not creating home directory is not reporter's home directory, but we can create the password. Password is mercy again. And full name is and room number Gaza. Work phone, no. Home phone, no. Other, no. Is it correct? Yes. So when I go up, ls-l, there's no reporter, right? Can this reporter log in? So I want to get another terminal. So Pi, so su dash reporter. So your reporter came here. So where is the reporter right now? Reporter is home PI because I created it, right? I created the reporter. So reporter can come in my desk. I'm the desk of New York Times. So reporter comes in me. So he can do something. Not in, for example, upload. He can do upload his file here. I'm not sure he can create file here. He may not, but because he does not have a shell. Touch reporter. Yeah, permission denied. He does not have a shell. He does not have the Linux shell, but he can push some file into here. Okay. And we can specify, for example, any specific folder to this user, not giving home directory. We can add this. Home directory is not created, but home directory is designated to some other places. We can give him or her some other shells, dash bin dash Z shell, not the bash shell. Ours is a bash shell. So this is what we looked at, right? So go up. We can set up expiration date also, as we said, with this option -E. So 2025, 12/31. So that reporters, the privilege is expired by the end of this year. We can give somebody's to the sudoers group, then add the user, this one's in the sudoers. Add a user to a specific group. That group is, in this case, a sudo. Once that guy is in the sudoers list, he can do that privileges. We can also delete finally. Sudo del user and username. If we want to, del user is to delete only that user. So all the work saved or created, owned by that user remains in our system. Only I will kick him out. Then we can use this. But if you want to see, hey, we do not want to keep any materials created by that person. You are fired completely. We don't need any work done by you. Then we need to do del user dash remove dash home. All the materials, all the work created by this guy will be cancelled completely. Directory permissions, that we already looked at, right? Okay, sticky bit. This is something new. Sticky bits ensures only the file owner can delete and modify their files. Somehow, according to UMask, unless I do explicitly change the mode, it takes the permissions designed by that UMask, right? So usually maybe modified, maybe deleted accidentally or purposely, but we can put some flags on that file. That flag is called the sticky bit. There's a 1 bit added more. Okay, so here this is right now there's no sticky bits. Okay, right now I do not want anybody deletes commands.txt because this is valuable to me. Then you need to do like here sudo change mode plus t and that file. Then no one can delete it. chmod no sudo, we need to put sudo. I'm not sure. Sudo without sudo. Okay, chmod plus t commands.txt. I think it works with me. Yeah. So what do we have here? No one cannot do execute. Delete is execute. So there's a sticky bit to that. But I can delete, right? Oh, I cannot even delete right now, unless I change this. So command.txt, right now here, he can read the text commands.txt. See if he can, he means Jaeyoon here, right? Can Jaeyoon delete this command.txt? Like remove commands.txt. Then it says remove file protected regular files. Remove. Protected remove write protected regular files. If I say yes, permission is not allowed, right? Anyway, so here, myself, I set this text the sticky bits. So I want to remove some other files. I can remove it without get that the questions. For example, rm numbers.txt, then it can be removed. Rm, right? This is removed immediately without, it doesn't ask anything. But if I want to do remove commands.txt, then it'll ask me. Oh, it doesn't ask me either. Because I thought it asked me like this, but it doesn't ask me. So yeah, I'm the person so that I can remove that. Because I put here T means this is sticky bit means I'm the only one who can delete. Okay. Any question so far? So this is useful. Commonly used in public or shared directories like /tmp files. There is a /tmp files usually available. Right now we have this kind of I do not know, but this kind of files are, without knowing me, these are temporary files. For example, if you want to post big files, not the text files, but big file, so that is image files or video files, then before it is saved at that specific location, it comes in first to that TMP files. Temporarily, it is stored when you upload in most servers. It's stored in TMP. When all the files completely shipped in that host, then that operating systems relocate that files to that originally designated location. You see that mechanisms? Okay, so temporarily in that temporary files, temporary folders. Why? Because over the course of that the posting process, there may be some errors takes place, right? Error can be expected. If it is expected, then why should we open that specific folder to get ready? So why don't we place it in the temporary location, and only we relocate that files when that file is completely available. Until it is completely available, the files is temporarily located at specific location, which is called the /temp. So see here something that we do not know, right? Those are, for example, pi. This kind of files saved, but we do not know. But if I know this, so that hey, this is valuable, I want to put that some sticky bits there, then you need to put here sudo chmod plus t for tmp /tmp/ what's the name of that? SSH something. So SSH dash something. Boom. chmod plus t. Is it small t? Big T. Yeah, it's a small t. So we need to do here small t. Okay. So now, if somebody's trying to see that, and that is sticky bits here. So he cannot remove this. These temporary files are accessed usually by anyone, right? I mean, by the systems usually. Okay. This we looked at what this means. So this the single digit, that is for other. Double digit is called the group, and triple digit is called the owner itself. And if we say the fourth digit, it is for non-special permission set. So usually we use these three numbers to change the mode. This is what we did, right? So we looked at change mode. Change owner, change group can be also possible. So right now, this is a change. This is, let's say, fruits.txt. It's owned by Pi, owned by the group Pi. But can I change this to ch? First, let's see. We have here Jaeyun. So when Jaeyun can see, Jaeyun cannot okay, I will do here sudo no ls minus l. So this is me Pi. I'm the Pi. So I can do change mode to group. Group can write on the greeting.txt. So greeting.txt, if anyone in that PI group can write that greeting.txt. Right now here's Jaeyun. Can Jaeyun write it? So for example, nano greeting.txt. So I want to add here one more extra by Jaeyun. So I want to add it, and I want to do write it. So Control O for write. File to write. I hit enter. It says error writing because the permission denied. Right? I do not have that permissions. So why I do not have a permission to save this? If I still want to, I want to save this. Yes, no, you cannot. So Control X, and then no. Why? Because these greeting files, I'm currently, is it greeting? So what is ls minus l? Yeah, ls minus l, the greetings. I'm now other, so I do not have any write privileges. But if I am in that group, Pi group, I may be able to, right? So how can I change the group? So change group. No, here it's not, right? Change group. No change group. So change group. Here we do change grp. Sudo Jaeyun to Pi. I want to make sure the help. So man change grp, change option group and file. So group name and file. So I need to do first the group name. Group is Pi for Jaeyun. It's not, it is file, not for the user. Okay, so group 1001. Here group is 1000. So if I can change the group to 1000, sudo I need to do user mode A. User mode add to and group. Okay, and group is pi Jaeyun. All right. So ID still it's not really changed. Permission denied. Still denied. That command, this command, Linux command is not available here in Raspberry Pi OS. Change group. What I mean by that here, I did this sudo user mode by adding to the group. This is group name to Jaeyun. Not changed. So Jaeyun is still 1001. Groups. Or can I put 1000? Still not 1000. But there's no error. Why is no error? So okay. But initially, when we create the user at the initial phase, then we can add the group there. Sudo add user. If you make a man add user, then add group, add user, add group. We can do add group. Why don't I use add group? Add group, add group, --gid to. Oh, this is the group. When you create a group, then we can do add group. To change group, man change group ownership. Change the group of slash change group step minus is that sudo change grp and then pi slash jyoon. jyoon. No such file directory. Or we can do let's see. Oh yeah. Oh no. Oh yeah. That is available in that levels. chgrp pi jyun, which means I want to change it. Originally Jyun's group is Jyun, right? So Jyun's group is Jyun. I'm not sure if it is changed now. Yeah, right there, still Jyun. But at this level, Jyun is in pi group. So this can be changed only like chmod group. If I want to do execute, I want to use the number 77704 pi. So pi access is right now. Pi owner, he can do anything. Pi is a group, he can do also anything. So Jyun is in the pi. So Jyun can do cd pi, or come back here. Jyun can do ls pi, right? Because he can access. He can do cd pi and ls minus l. Yeah, because he's the owner. Because, and also I said here at this level, the group, which is a pi group, can do read write access. But I changed the group of Jyun to pi, same as pi itself. So Jyun can do something specified in this pi permission. Okay. Question? So this access control is very, very sensitive. So you have to make sure it is really controlled the way that you plan. The way that I showed it to you, right? Some works, some doesn't work. Then make sure it works. If it shouldn't be working, then it shouldn't be, right? So you have to control that way. Okay. That's what we did. Okay, tar. This is a compression of the file. tar stands for tape archive. Tape archive. Still, if you want to archive some files, tapes are popular. Okay, the life of tapes may last long. I think lasts longer than a CD-ROM, I believe. Tape itself. So they want to archive some files on tape. So we can do tar files. If you want to make a compression, so I want to practice it. Go to John Yun. There are that many files. So if I want to do tar, and then if you want to archive it, then CVF is usually used for that. CVF. If you want to extract it, then XVF. This is for unarchive, C for archive by compress. So we can do XVF, and then everything here in these files. Yeah, before we do, we need to make a file name. So I can do all.tar. So tar, all.tar, that is my target. That is the tar file, archival file that contains tar CBF. Let's see. Yeah, we need to have an option number here. So tar minus CBF, and then tar file. I would say that is all.tar. That contains everything. Star. Hit enter. Then everything can come in. And then if I do ls, I have all.tar files. This is the tar files. Okay. So this tar file is handy to transmit. So I would say here JUN has that all.tar files. So I want to copy JUN. So cp all.tar to my home directory. So tilde. Then it'll come to my directory. Now I want to do exit. Right now I'm in JUN. I'm in that directory. So I can come back, cd. So my home directory JUN. So ls minus l. Then my home directory, I have all.tar files. Okay. Now I want to extract the files in my directory. Then I need to do tar extraction xvf, v for verbal, as it is executed. Executed. In this case, unarchived. I want to see all the verbals, so all the files that I can do. Which one that I want to see? I want to see the files. So xvf and all.tar. Then when I hit enter, then I can see the list of those files. Hit enter. So that I can see those files. So from this command, I may be able to see which files is now extracted. If I have millions data, then I can see all the files. File list can be scrolling. Okay. Usually, tar files is to deliver massive file structures. The beauty of this tar file is that file structure itself is carried over. So see here. Then I have the directory itself also carried over, right? So that I have cd February 24. Then I have that file. Nothing there, but that directory is carried over. After this, we need to remove all.tar. No such directories. So tar file is, that is there. So remove all.tar, then that is removed. So I have all the files that this guy has. Okay. I think this is all that we planned for today. Any question? I believe this is the last one. Some of the exercises that I want to do. Yeah. Any question? Yeah, this is kind of, link files. This is something new. This case, everything is here. We moved all the files using tar files, right? Let's say I have temp file here. I do not want to move this file to JUN, but JUN can do everything that I have. Here, copy files is this. Let's say two users. This is a Pi user. So Pi user has his home directory, and Jae-yoon has his own home directory. Right now, using tar, if it is a tar file, then tar file is copied over to Jae-yoon. So it can be exactly the same structure can be moved to, not moved, copied to other location. That's what we use tar. The link is something different. I have here a file, but this guy does not have, I do not want him to store that file itself. I would say here dotted box, but rather this guy can do as if that is there, but actual physical location is here. Physical location is here, but I want to give him a link. So whenever he comes here, then physically that is there. That we can say ln for link. Okay. So here, ln minus s, I want to make a symbol link, and that is home Jae-yoon. There, I would say PyTemp to here temp. I want to make a symbolic link, so it'll be created here Jae-yoon's directory, where there is a jp underscore temp. This temp file goes to linked to, therefore linked to Jae-yoon. Therefore Jae-yoon is allowed Jae-yoon to access my temp. Okay, I don't want you to copy mine, but you can access mine always. So the physically that is under me, but you can do as if it is under you. That is a link, ln minus l. So I want to make it here, enter. Let's see what happens. Failed to create, oh, I need to make a sudo. Failed to create the symbolic link temp file exist. Sudo ln. I think this should be opposite. This temp goes to there. Temp goes to over there. So hit enter. So when I come back here, I have jp underscore temp, right? So when I do ls minus l, then I may be able to see here, this guy starts with the L, okay? The permission list, permission code here, if it starts with the D, that means a directory. It starts with the D, then there is a link. Then we can see where it is. It is a jp underscore temp slash temp. Let's see. No, this is not correct. So we need to, I want to remove jp temp. Okay, you should be very carefully. This is not just a temp, it should be current temp. So dot, not any temp, but my temp here. You can say dot temp, or you can say home dot pi slash home slash pi slash temp. I want to make this temporary file, which is my file here, temp, that's linked and available for him to read, like here. So I want to put here, rather than jp temp, I would say j underscore temp. so that you may be able to see it more clearly, differently. So ls minus l, then you have j underscore temp. See here, this is a link, j underscore temp. It goes to, when you open this, it goes to /home/pi temp. Okay, so right now, when I see temp, it has hello Mercy.221. Here Jayun has only the link. So can I see that? So when I see cat j underscore temp, then I have permission denied. Read or write, read. Temp. Cat J permission denied. Why is it denied? This is nothing, right? Right now, temp has read write, so we can. So at this pi side, if we change mode to 7772 temp, so temp can be do anything. So if I do j underscore temp, permission denied. Oh, this is a root. Oh, that is the reason. It's a root. Oh my gosh. So what should we do is here, change owner of home.sudo change owner home.jyun and j underscore temp to jyun. Invalid user. Why am I here? pwd jyun. Change owner. Oh, I need to make here. Yeah, owner jyun for that files. So that is changed. So that if I come here, the owner is still root. Sudo owner. Yeah, I think that is because it was. Let's make sudo here, ln here. This is something messed up. Why? Because this is root. So I want to make a link ln minus s, and then home.pi.temp to my new temp ls minus l. I have a new temp here. This new temp is owned by me and group me, so that I can do cat new underscore temp, then I can see that files. Permission is denied. jyun temp ls minus l. This is a mess. I'm not sure why this is a mess. Okay, let's make it clear. So copy temp to temp, so that I have two temps. I want to make ls minus l, so that is owned by pi. So I want to remove original temp. minus L. Okay, now I have temp. So I want to move this temp to temp. So I have one temp, and the temp contains hello Mercy 221. Let's say cat new underscore temp. Still not. This is strange. New temp. Why permission is denied? Let's see. I think this is a pi. That may be the reason. I want to change one more thing. So I want to do change mode 777 to that pi. That way that guy can come in, I guess. So I want to do cat. Now I can see that, right? You know what? When I do this, new temp, it goes to home and pi. When I compile pi originally said here, others cannot do anything, right? Dash, dash, dash. So I open that one to anyone so that I have now this pi directory has RWX. Originally, there's no RWX. So even if that is linked symbolically, so when I try to access that, permission denied, that denied only because of pi itself that blocked, because pi is not open. So when I open this pi, therefore I can see the temp files. Okay, this is very, very sensitive. So you have to make sure along that path, whether any points are blocked. Okay, so that you have to make sure through all the path, everything should be open all the way to that specific files. Then you can see it. So this is another good way that you can protect. You can protect your files, right? Although it is linked to someone else. Once you protect this, let's say I want to change mode 770 again to pi. This is home. We'll go up one more, and then change mode 770 to pi. Where? Oh, there's a home. All the way up. So here, if I do this, then I cannot read it. Permission denied, right? When I open this, then I can read it. I can read it, right? So in one hand, it is sensitive. At another hand, therefore, we can manage it tightly, securely. That's what we can see. Okay? Any question, any comments? I think this is good stuff, so I want you to practice.